Hi, good afternoon. My name is Wei Hu. I'm here to share with you what we're doing around Kubernetes and microservices with the Oracle Converged database. To start with, I have this love-hate relationship with Kubernetes. I think it's really great technology, but it's still very hard, right? And according to surveys, Kubernetes really is taking over the world, right? It's becoming the standard for deploying containers in production, developers are embracing it, and so forth, right? And many microservices applications are deployed in containers managed by Kubernetes. That's the good part, right? The bad part is that running Kubernetes in production is still quite hard. So in this talk, I want to talk about how Oracle is embracing and innovating in the space to make it easy for you to deploy enterprise class applications on this technology. To start with, I just want to reassure you that the Oracle Database 19c is fully supported in containers, whether it's Docker, Podman, and we release container images for the Oracle Database, and you can freely download them. And these images are supported for production use. Okay. Now, the rack is special. It's that it's supported only on premises, and for the cloud deployments, we recommend that you use Oracle's managed cloud services, like the Autonomous Database and so forth. And the rack images, of course, assume that the underlying operating system and hardware are also supported a rack. And we release these images for the base releases, and you can freely take them as base images to build your own customized Gold images with patches and so forth. Now, there are many Kubernetes distributions out there, right? So what we do is we test the support against the Oracle certified Kubernetes distribution. And then we also support these images on Red Hat OpenShift. Because we heard from you, our customers, that it is what you want, right? And so we basically test the same Red Hat OpenShift releases as for the Oracle certified Kubernetes distributions. And there are details about how this works and so forth. So for me, providing the Oracle database images on Kubernetes is an important first step, right? But we want to go further and make the Oracle database Kubernetes native. So what does that mean? It means that you can perform all the lifecycle operations you want on Oracle database natively as part of the Kubernetes infrastructure. And we want to be able to do this whether the database in the cloud, running on premises, inside a Kubernetes cluster, or even outside of the cluster. And there are really two aspects to this. First, we want to make the Oracle database natively observable in Kubernetes. Secondly, we want to support the Kubernetes operator for the Oracle database. Now I'll talk about both of these in turn. Observability. Okay. One of the great things that I really like about Oracle database is that it has very rich performance and runtime statistics. You can look at all the views and statistics and find out exactly what's going on. Okay. And what we're doing is we're making all of this data accessible via popular open source frameworks that actually turns out to be used with Kubernetes also. So we're building extensions to Kubernetes. They're called operators, exporters to publish database metrics. We publish best practice for using Loki to monitor and aggregate logs, right? And we provide Grafana dashboards to display all this data together. And as before, we support the Oracle database deployed within and outside of Kubernetes. So this allows you to do end-to-end monitoring tracing of your entire application. And on the right-hand side, you see two screenshots of what a typical Grafana dashboard looks like. Okay. And of course, all of this is available on GitHub. So you can incorporate into your own customized dashboards and so forth. The next part that I talked about is the operator for Kubernetes. Operators are extensions of Kubernetes to manage applications. It allows you to basically run the Kubernetes command line, kube control, to manage the lifecycle of an Oracle database. So for example, this command here is how you can provision an autonomous database from within Kubernetes. And notice how it just looks just like a native, actually it is a native Kubernetes command, right? And the magic part of this is that the Oracle database that is being managed by this operator can be running anywhere. Right? It can be running inside the same Kubernetes cluster. It can be running outside of Kubernetes cluster. It can be running on premises or in the cloud. It can be running on the same or different clouds. Right? And the way we accomplish this is by providing multiple operator backends. We call them controllers. Right? And so our goal really is to make the Oracle database deployed anywhere natively manageable by Kubernetes. And here's the architecture diagram that shows how it works, right? You run your kube control and directed at a Kubernetes cluster, right? And that's where the operators run. And then the operators have multiple backends, and one controller manages containerized Oracle databases running inside a Kubernetes cluster. A separate controller can manage databases running inside the Oracle Cloud, like the Autonomous Database. And the third controller actually manages on-premises databases, including Exadata. Right? And so, we support all these configurations. We support the lifecycle operations you expect: provisioning, backup, start-stop, so forth. And we plan to support all the major Kubernetes distributions and clouds. So this is the roadmap. As this is ongoing work, right? What's available today is support for the Autonomous Database, as well as Oracle-based databases. So basically, databases running Oracle Cloud. We support single instance and sharded containerized databases, right? As well as on-prem databases. And we've tested on a variety of distributions. Okay. And very recently, we've got certification with OpenShift. And our plan is to continue this within the next 12 months, release the first production version, release rack support for rack containerized databases, add observability metrics log tracing, and test on additional Kubernetes distributions and clouds. So I just want to summarize. So right now, what I'm saying is that Oracle is embracing the use of containers in Kubernetes. We support container images. We have Helm charts for configuring these images. We have adapters for Kubernetes open source observability for tracing frameworks for Prometheus, Grafana, and so forth. And we have the operator. And all of this is open source and available in GitHub. So next, I want to talk about what we're doing to innovate to extend containers to Kubernetes to support high-end OLTP. Now, here's a reality check, right? Kubernetes is hot technology, but it turns out that very few organizations are actually deploying Kubernetes for business-critical applications. And this is what people have been saying, and this is what we're seeing, right? And one of the reasons we think is that lack of infrastructure, right? So for example, currently, real-time high-throughput OLTP applications use transaction monitors, such as Oracle Tuxedo and IBM CICS, okay? And they're widely used in money transfers, credit card systems, reservation systems, and so forth. Okay? And we strongly believe that microservices applications that want to deliver the same level of performance and reliability need similar capabilities. And this is what we've done. Okay? We built in a capability called MicroTx. It provides lightweight fault tolerance for microservices. So what MicroTx does is simplifies your application development by coordinating cross-microservice consistency in the presence of failures. Because with microservice architecture, you have multiple moving parts which need to cooperate to get things to happen. But when things fail, you need to be able to handle failures and so forth. Right? And so MicroTx supports the REST-based try, confirm, cancel, supports long-running Sagas or traditional XA. Okay? And this also works with database-native log-free value reservations that I'll talk about later. Okay? And MicroTx is lightweight. It's a very simple API, so it's easy to use and deploy, right? And it's integrated with and deployable within Kubernetes. It supports the popular languages, frameworks, and even non-Oracle databases. And best of all, for developers, MicroTx is free and is available today. Okay? And then, in fact, there's a recorded session that you can look into that talks about MicroTx. Okay, so after MicroTx, I want to talk about the other thing we do is something called the Oracle backend for Spring Boot. Okay? There's a mouthful, right? So microservice applications do not run in isolation. There's typically a front end and a back end, right? The back end consists of a collection of services: Kubernetes, databases, API gateways, messaging system, monitoring, security, and so forth. Right? And deploying and managing this backend is very complicated. So what we've done is, in December, a few months ago, we released a preview for two backends, one for Spring-based applications. Now, Spring is the most popular Java development framework out there. Okay? And we also released a preview for a parse for mobile development. Okay? And our goal is to have this backend so you can just deploy your Spring application or parse application into this backend with all infrastructure in place. And this backend, our plan is to support this everywhere. In our cloud as an OCR marketplace offering, on premises, so you can deploy it as a service in your own on-premise infrastructure, as well as non-Oracle clouds. And here's a picture showing you how it works. You can see that it's a whole bunch of infrastructure software, right? Plus Oracle Database, of course, API gateways, and so forth, and then containers, right? Kubernetes with containers. And the goal is that you develop your application using Spring, say in Visual Studio Code or something. Then you deploy your application into these runtime containers, and then you have your entire app ready to go. All right, so I spent a lot of time talking about containers, Kubernetes, and so forth. Now I want to talk about microservices architecture as a whole. Microservices, like Kubernetes, are attractive but hard. Okay, and if you search on the web about experiences of microservices, it's actually very, very depressing. Okay, you see things like microservices failures, why many microservice projects fail, 11 reasons why you are going to fail, and so forth, right? And so we looked at this and realized that we really want to aim for success. And I think there are two key aspects to aim for success. One is use the best tools available to support your microservices development. And secondly, follow proven architecture patterns. Do what works. Okay. So in terms of the best support for Kubernetes, that's what we've worked very hard over the years to do for the Oracle database. So for example, we have in-database containers, which basically implements container concept natively in the Oracle database. And these are what's called pluggable container databases. And so the idea is that every microservice gets its own pluggable database, right? And it's like a virtual database. So that you don't need to deploy a heavyweight physical database for every microservice. Each microservice gets its own isolated, pluggable virtual database. But the key thing is that many pluggable databases can be deployed on top of a single physical database to simplify operations. So that if you have many, many pluggable databases, you don't have to manage them separately. You can manage them all at once as a single physical database, right? So that gives you the isolation, the autonomy for each of the microservices, but still gives you the ease of manageability of a consolidated database. And of course, pluggable databases can be easily cloned and moved between physical databases. So you get the flexibility and the agility. The next thing is that the Oracle database built-in support for transactional events. Microservices, by definition, is a loosely coupled systems where the microservices talk over either REST or over event systems. So the Oracle Transactional EventQ, short TxEventQ, is a free event platform built into the Oracle database, and it's been there for 20 years. And it's been continuously enhanced. The previous incarnation was called Advanced Queuing, or AQ. Transactional EventQ simplifies microservices development. First, very key thing is that the published consumption of an event is transaction integrated with data changes. So this eliminates a lot of failure modes. And I'll talk more about this later. This is a very powerful capability that is unique to transaction EventQs. And this capability handles difficult cases like events that change the database state and produce more events. Make sure it's all atomic. It provides exactly one semantics without the heavy two-phase commit issues and without having the application deal with idempotency issues. And of course, since it's part of the database, security, backup, recovery for events and data are tied together. So you always get them consistent. And TxEventQ has a scale architecture can handle 1 million events per second, so it can get as big as you need it to be, right? And we implement transactional cross-database event propagation without two-phase commit again. And furthermore, for those of you who are interested in working with Kafka, we also can use the Confluent source sync connectors to enable event shipping between Kafka and TxEventQ. So this gives you the best of both worlds. You can work within an Oracle database system with TxEventQ with very strong semantics, and if you need to connect to external system, connect using Kafka. In database 23C, for which the developer edition the free edition is available imminently, right? We added some new features. First, we support Kafka Java APIs as well as the Confluent Kafka REST APIs, right? Because we want to use APIs that developers use it. It's higher performance. We implement adaptive in-memory caching, so you run at memory speeds for most NQ/DQ operations. We parallelize Q-to-Q propagation, parallel consumption from a single event stream, so you have multiple consumers consuming parallel, as well as dynamic event stream consumers. And of course, consistent with everything else we've said, we support integrations with Prometheus and Grafana, so you can use Grafana dashboards to look at how DQs are doing and so forth. Next thing is native Saga supported database. Earlier I talked about how Saga is a way of coordinating distributed operations with microservices, right? And so that's what Sagas are. It's a way to orchestrate multiple microservices in a single business transactions. And so this is really designed for applications that are long running with microservices that can take a while, right? And in these situations, you really do not want to acquire global locks because it just ties the resources for too long. And so the way that Sagas work is that individual microservice transaction can commit as they complete. However, if the overall business transaction is aborted, then the individual microservices must undo the effects of the commits. And this is done using compensating transactions. So for example, if you made a deposit, you need to come back and do a withdrawal to undo the effect of the deposit. Now, writing the code for compensating transactions can coordinate the commits and rollbacks of the microservices that goes into this transaction can be complex and error-prone. And before I go into that, I want to show you just how this works. So for example, the Saga is supposed to go on a trip. I need to get airline tickets, a hotel, and a car. If I can't get all of these, I'm not going on the trip. So I would book the airline. Suppose I succeed. I book the hotel. When I succeed, then I try to book the car. Right? Now, if I fail to book the car, I will have to roll back the entire transaction. Now, of course, these two roll back the entire business transaction. Right? So what we'd have to do is come back and undo the effects of all the commits. So first, I got to compensate for the airline ticket. I basically got to return the airline ticket, refund it. I got to cancel the hotel reservation and so forth. And so this is an illustration of how Sagas work. There's an overall business transaction, and the individual steps, like booking flights, hotels, cars, can commit as they go. But if the overall business transaction needs to be rolled back, you need to be able to go back and undo the effects of your transactions. Database 23C simplifies the Saga pattern. Right? First, we have a built-in Saga coordinator in the database. So that means you don't have to install and configure a separate Saga coordinator. And this coordinator can manage Java and PL SQL microservices running inside a database or externally in containers or bare metal. Secondly, we have this concept of auto-commenting columns or log-free reservations. But changes to this type of columns are automatically undone if the Sagas were rolled back. And this basically supports numeric types, numbers, floats, integers, where the computation logic is well defined. So accounts, make a deposit. If you want to abort the overall Saga, you can automatically does a withdrawal and so forth. Right? So this eliminates the need to write computation code. Right? Then finally, of course, the Oracle TxEventQ is the event mesh that we use for Saga coordination. And the exactly what semantics of TxEventQs makes this reliable and recoverable. So that means you don't have to set up and manage event streams among the Saga initiators participants. And so our goal is with all these three things combined, to make it easier for you to deploy the Saga pattern. Then there's, of course, the data refactoring advisor, which is that many times customers want to migrate a monolithic system to a system of microservices, and it's hard. Right? So, but the key observation that we make is that a data-driven application, database application architecture, is strongly determined by the way the data is organized as a schema. Okay? So how you factor an application into microservices is strongly correlated with how the schema itself is factored. And so the idea is that you factor your schema into separate data sets that can store in different PDBs, then factor the associated code in the microservices. And that's what this does. Data refactoring advisor is a tool that identifies groups of tables that are frequently accessed together to help you decide how to formulate these subsets of your schemas. Right? and it uses the sequence tuning set data, and then uses the graph database for community detection. And then this can be used in conjunction with developers to figure out where are you, how to structure your application. And here's just a picture of what the graph looks like. All right, so I talked about the microservices support building the Oracle database to make things easy. The second part that I talked about was key microservices patterns. So, and I strongly believe that this follow the practices that works, use proven architecture patterns. Right? And the Oracle database simplifies key microservices patterns. And here's some of them. Okay? And I'll talk through a few of them. First, the one that I like the best is this thing called the Transactional Outbox. Right? It basically allows you to write the data into a table and publish an event as a single transaction. And traditionally, this is a very complex pattern that involves application code to make sure that the update and the event publish are atomic, right? Because what if you update the database table but didn't send the event? Things are messed up, right? Well, it turns out that with transaction event queues, we simplify this by atomically persisting the DML and the event. Okay? And we maintain total order with each event stream, and we can recover from any kind of failure, same as database recovery. And we provide exactly one delivery events. And we do this because our transaction events are also database events, and that's why we can make them part of the same transaction. Okay? Having a built-in transaction outbox makes your application code much simpler. Then the other one is, of course, idempotent consumers. In real systems, events can be lost or duplicated, and you have to handle these cases. So, for example, event consumers must be idempotent. I detect and ignore duplicate events. Suppose I receive multiple requests to withdraw $5,000 from a bank account. You want to make sure that they're actually separate withdrawals and not repeats of the same withdrawal. Right? And the Oracle Converged database simplifies the idempotent consumer pattern for microservices by supporting strong exactly once event delivery. It handles the failure case you might expect: crashes, network failures, one-time recovery, failure of disaster recovery side. And it's easy to use and does not require distributed two-phase commit. Right? And now some other systems claim to have at most one semantics, but actually doesn't work through various error conditions and so forth. And the key is, with this pattern in place, consumer code does not need to do any deduplication. That simplifies your code and makes the logic much cleaner. And I thought I'd just show you a picture of what the simplification means for you. On the left-hand side is a heterogeneous architecture that shows an ordering service and inventory microservice running with Apache Kafka, running with MongoDB and PostgreSQL. Right? Then the blocks of code in pink are the things that you have to handle. You prevent duplicates, update the table, produce events with code to detect failures and handle duplicates and so forth. And you can just see there's extra code you have to write. Okay? On the right-hand side, it shows you what happens when you can use the Oracle Converged database with a built-in Transactional Outbox and exact once event delivery. Okay? All those pink blocks of code go away. You don't have to write that code. Okay, this is much simple. No code is simple code, right? And there's a hands-on lab that actually walks you through how to build these two styles of applications so you can appreciate the difference for yourself. Event sourcing. I think I will skip this in the interest of time. Event aggregation is actually a very interesting pattern. Okay. Event sourcing, which I skipped, unfortunately, stores and replays all the events in a stream. Okay. So basically, what event sourcing does, it recreates a state by brute force reprocessing all the events. Right? That can be expensive. Right? So event aggregation is actually a more interesting pattern. Right? It basically uses a database to represent the state of all the consumed events. Right? Because the idea is that to read the current state from the database is far more efficient than reprocessing all the events to recreate the current state. It's almost like in some sense, the database is the ultimate compacted topic. And so I think event aggregation is actually a very interesting pattern that you should look into further. And that we support natively with the database. So I sort of did a very quick tour of the microservices patterns, right? On this slide is really 11 patterns. I'm not going to go through all of them, but I just want to show you what they look like. You know, bounded context. How do you break up a monolithic microservice, data refactoring advisor? loose coupling, you're using a reliable event mesh, you have CI/CD, security, observability, transactional outbox, reliable event mesh, aggregation, CQRS, and so forth. Okay. So the idea is that we've systematically gone through a lot of microservices patterns and sort of describe how you can use the Oracle database to apply these patterns to ensure success for your applications. Okay. And we think that this makes it much, much easier for your applications to work. Okay. Because getting applications to run well is one thing. Getting to run well in the presence of failures and so forth is another thing entirely. And hopefully with these proven patterns, it will make life much easier for you. So I just want to summarize what we're doing around Kubernetes microservices with the Oracle database. First, I've shown you how we are embracing extending Kubernetes, right? With the Oracle database Kubernetes operator, by adding MicroTx to support mission critical applications. Then we're releasing the Spring and Parse microservices backends based on Kubernetes, as well as popular framework, Spring, and so forth. Then we are building microservices capabilities into the Oracle database, like in-database containers, events, transaction event queues, Sagas, right? And lastly, we're promoting the use of proven architecture patterns that take advantage of the capabilities of the Oracle database. So for example, things like Idempotent consumers, Transactional Outbox, and so forth. And so our goal really is to make you be more successful in applying these technologies, which have great promise, but which can be challenging to deploy otherwise. And I just want to end it with a slide because there's plenty more that you can find out about these topics. So I've put links here to our live lab so you can actually go through the exercises and touch the software and see for yourself, right? Then various blogs and so forth that talk about different aspects of these topics in greater detail. So with that, I guess I want to thank you and hope a good rest of your day for you.